Okay, so I'm just going to give you a quick reminder. This unit has three main, read the booklet, three main categories. You ready? Triangles, four-sided quadrilaterals, and then polygons. Polygons. Do you mind turning off the front lights for me? Thank you. So make sure you follow along. Put that screen away. And so here we go. To classify, what does classifying mean for us? What does that mean to us? To classify. Identify, yes, Nathaniel? Name, yes, name. Yes, you give it a first and a last name. I call it that. It doesn't have to be. And make sure on your study sheet you have classifying, naming it. You have the three names that it has when it comes to the side lengths, and the three names it could have when it comes to the angles. Okay? Will there always be numbers on those triangles they ask you to classify? No. Sometimes there will not be any numbers. You have to go by markings. If there are numbers, specifically angles, please find them. Okay? So yesterday we did a couple, so let's go to page 8 here. I will tell you straight up, this booklet goes above and beyond what you need to know. That's why I'm skipping some pages, okay? That's why I'm like, I just want to cover what you need to know. And if we want to have fun, you can do it over the summer. I'll post a key online if you want to do the harder ones. This one, for example, if you had to give it a name, it's a triangle, all right, but it has to have a first and a last name. But Nathaniel? Isosceles? Because you're seeing these, right? Can I ask you to hold off a little bit with isosceles for a bit? Let's do a little further investigating. These two sides are the same, correct? We don't know what they are, but they're the same. If there's a 25 across from this one, what will this angle be that is across here? 25. There we go. Once you've got two angles, you can easily find this angle. We just go 180 minus 25 minus 25, right? That gives us 130. If you can find the angles, please do that. Okay, it's gold. Now, this is still isosceles, so let's do that one. And in terms of angles, what would this be? Obtuse, yeah. Because it's got the 130, okay? Don't do this when you name it. I'm just letting you know why I called it obtuse. It's got the 1, this is greater, okay? Greater than 90. That's what it says, I promise. Okay? Greater than 90, and that's why it's obtuse immediately. Maybe I'll do this one because this might show up at some point. We'll skip at the very bottom of this. Here, what if you had a triangle that looked like this? Yeah, it's a Dorito. Yeah, don't say that, I'm hungry. You would probably be tempted to say isosceles right off the top. But do a bit more investigating, right? Some of you are seeing it. Like, if this is 60, then this is also 60, which means this has to be 60. What kind of a triangle is this? Equilateral. So, acute equilateral, even though the province will be okay if you just say equilateral. I would, just to be safe, still say acute, because there's no such thing as obtuse equilateral, correct? Because it's always 60. There cannot be an obtuse, that's a contradiction. Okay, we got that figured out. So that's why I said investigate, if you can. Okay. Let's do this one up top here. Isosceles, right? That's what we're thinking. If this is 80, we can find these ones. Because this is angle A and this is angle B, let's say. We can find both of them. How? Focus on one of them, A. 180 minus 80 divided by 2. So that'll be 100 divided by 2. That's 50, right? So we now know that this is 50, and we also know this is 50 because remember, the angles across the equal sides are also going to be equal, guaranteed. So you can find, you could have even guessed, like what are two angles that are the same that will make this 180, right? 45, 45, that doesn't work. That's 90 and 80, that's 170, right? So you could have even guessed and you would have been fine, okay? So now we have a way to name it. What will we name this? Isosceles, right? That's one of them. And the other one, acute. Okay, because all angles are less than 90. 90 is kind of like our measuring for angles. It's either exactly 90, then it would be a right, less than 90, acute. If there's one angle bigger than 90, it's obtuse. What about this one here? No numbers at all. Obtuse, scalene, right? Because all three have different markings. And in this case, all we had to go off of is that one. I'm going to be honest with you, I don't think the province will, they might. They will just say this is not drawn to scale, but let it guide you. Right? That is the obtuse angle right there. What about this one? Do we know this angle? Yeah, it's a 90. We can go, to find this one, we go 180 minus 90 minus 45, and we end up with 45 again. What kind of triangle is this now? It's a right, yeah. Isosceles because of the two angles being the same. We're guaranteed, if you want to go arrows, we can actually put a marking here and a marking across the other 45. It's always a cross, right? Right, isosceles. I don't want you to leave these ones blank on the exam, okay? You give it a try, you name it to the best of your ability. I will put a twist on this. I've seen this, okay? Just copy it at the bottom of 8 here. I'm gonna go like this. This is 30. This is, yeah. What is that triangle? The triangle, what would you name it? You're like, I don't know, right? If this is 120, do you remember supplementary angles? And they're side by side like this, like connected by a straight line. It's 180 degrees here, right? So if this is 60, correct? If this is 60 and that's 30, that's 90 already. Take that away from 180. You actually have a 90 here. Right? Right. So this would be a right what? Is it acute? There's one. The acute you cannot use anymore because it's acute right obtuse, right? In terms of angles. Scalene. Right? Why is it scalene? Because all three angles have different measures, which guarantees you that all three sides are going to be different. Okay? Scalene. I will make a note. All angles are different. So for the naming it in terms of angles, you need the actual number. To name it in terms of the sides, you don't need the side lengths. You just need the angles as well. So angles are gold, okay? They're gold. I hope you're understanding the concept here. Use what you've learned so far. I'm even gonna say this. They mix geometry and trigonometry on the exam. They mix it up. This is gonna be mixed in with sine law, cosine law. Are you awake for this? Right? It could be that they ask you to solve for a missing side on a triangle using trig, right? So you might have to use sine law, cosine law. There could be a B part saying, now that you found that missing angle, what would you name that triangle you just solved for, right? They might be clever in combining it, which shouldn't be a problem for us, right? We know how to name a triangle just by looking at it, okay? So I'm not mixing up sine law, cosine law a whole lot here, but it could be. Let's see here. Let's go to page 9. I want you to name 3, 4, 5, 6. Those 4 there. A minute per question, let's put it that way. It should be less than that, to be honest. 3, 4, 5, 6 on page 9. Investigate. Okay, let's see here. 3. Make sure you follow along, okay? That 45 is across that one, which means that this one will also be 45. 45 and 45 is 90. So take that away from 180, you've got a 90 here. This is a right. You can only pick one from the 3. Right, acute, obtuse, right? So right, you pick that one. You cannot take from that category again. And the other one is isosceles, yes, in terms of side length. Yes, good. This one, I notice that these numbers are the same, which means that the side lengths obviously are equal. I can find these and I know they are the same. So I basically just go 180 minus 70. I'm left with 110. I split that in half. It's 55. So each angle here is 55 degrees. So this will be isosceles for sure. And in terms of angles, it will be acute, right? Because they're all less than 90. So there we go. This one is a little trickier. What would this be in terms of side length? Scalene, okay. What about angle though? Obtuse? Do you know for sure? When you have side, 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 what can you do? Which one should you check for? The biggest angle. Where is it across from? Okay, so this is the one that I'm not sure if they would ever do this to you, but I want to prepare you for it. Let's call this A. This is the largest angle. That's the only one you need to check for. Because if this one, listen carefully, this is my logic. If this one is less than 90, we know this thing is acute, right? Because the other ones are all going to be smaller. If this is exactly 90, right? If this is greater than 90, then it's obtuse. So let's just do the math here. Cosine of A, you just make sure this is the negative that back here. Okay, make sure you subtract this one, and then you take the other two. 5.1 squared plus 6.8 squared. And at the bottom, it's 2 times 5.1 times 6.8. That's just how it goes. I'm just going to go get the key on this one. Oh, I didn't do it. Shame on me. Oh, no, I do. Okay, listen to this part. When you do this, anybody tried it already? You get 0. You get 0, so you're not doing something wrong. What do you get in the bottom? You get 6936. What is 0 divided by anything? It's always 0. What do you do now? You might think you did something wrong because we didn't talk about this during cosine law. To find the angle, what do we do with that decimal we normally get? We go inverse. What do you think that's going to be? 90? Try it. Second cos of 0 is 90 degrees. So now you learned something new, right? So this is a 90. So what can I put in terms of angles? Right. Question. Listen to this part. What if this was a negative? Do you remember that? Then it's an obtuse angle. Yes. If this is positive and a decimal, it's an acute. If it's 0, it's 90. Okay? So I will say this. 0.123 positive, right? It's acute. If it's exactly 0, it's a right. If it's negative 0.1234, right? If it's negative, it's obtuse. So if you want to make a little note, under cosine law, sine law, right? When you're trying to find the angle, that's something to remember. Okay? All right, let's, will this happen often? I need you to be prepared for it, because cosine law, quite frankly, you should know how to do that. I will ask you to go, we're going to do it the other way. If I ask you to sketch it, how would you do it? So go to 11. What if the province asks you to sketch an acute scalene? Would you be able to do it? Yeah. It isn't that hard. I would say just make sure if it's a scalene, you make it look off-centered like this. Just make it look off-centered. And what do you want to make sure all angles measure? Less than 90, correct? So let's try something. I'm going to go 60, 40. What does that add up to already? So this must be 80. So check, acute is done. Is the scalene part also done? Technically, yes, because if all angles are different, all sides are different. But if you want to make your point loud and clear, you can go like this. That is also okay to do that. But technically, we were okay with having all different angle measures. You're done. The province would say 2 out of 2. What about obtuse isosceles? If it's isosceles, it's a symmetric triangle. So I would try to make it look symmetric, meaning if you cut it in half, you've got 2 same halves. This is as easy as this one goes, guys. Watch. That makes it isosceles. And then I'm going to say 110 at the top here. Or you could say 91 if you wanted to. Anything bigger than 90, you're good. You don't even have to have the other angles there. Okay. Try doing C to F. See if you can do that. And yes, yours might be different than my answer key. That is fine. I'm not saying that's wrong. We just have to make sure we follow the criteria. Okay? So I'm gonna keep you on your toes, right? I'm gonna do a little bit and move on, and then progressively go into maybe a bit more challenging stuff. So obtuse scalene, you can possibly do the same, but just make sure if it's scalene to make it off-centered. And I will just put like a 98 or something. Has to be bigger. And this makes it scalene right here. I just have 3 different markings like that. Right isosceles. You can have it like this, and have this and this. Or if you'd like to have the right angle at the top, that's fine as well. So all those are right scalene, right isosceles triangles. Equilateral, please get this one right. What do we know about the angles? Which is 60. That's more important. I mean, I do need you to know that they're all the same, but they're always 60, and that's good. Acute isosceles, remember if it's isosceles or equilateral, it's symmetric. So if you do this, you're fine. And how are we going to do this? Isosceles. 50 and 50, that will make that 80, right? So I'm just going to go with 50 and 50. And then that's 80, that adds up to 180. So just be smart with your numbers. If you pick 30 and 30, that's 60, then this would have to be 120. That's a problem, right? Are we good? Again, this isn't just one way of doing it. You find your own way. Okay, page 12. Classifying triangle where some work is required. If this is 120 here, I know I have a straight line here. So if this is 120, then I know this is 60. If this is 150, I do see the straight line here again, right? It's sitting there. If this is 150, then this is 30. I already did this, didn't I? But anyways, then this is 90. It doesn't look like a 90, but they will always say it's not drawn to scale. That's their cop-out for not having to worry about it. Okay, so this one would be a right scalene. Next, there's a 90. If this is 90, that's 41, then this is 49. So this is a right scalene. Okay, right scalene. What about the last one here? Anybody try Pythagorean theorem? I know you can use sine law, but this is a right triangle. There's nothing you can do about it. That 90 determines that this is a right triangle in terms of angles. So what is this, a leg or the hypotenuse? Leg. So you could use leg is equal to hypotenuse squared minus 2.8 squared. And that is, one second here, minus 4 point, no, that's not it. I'm just going to do it real quick. 7.37. Take the root of that. That's 2.71. So this is 2.71. So what do I know now about the side lengths? It's scalene, right? It's close, but it's a right scalene triangle. They're all different. So if you can use your previous knowledge, why was I able to use Pythagorean theorem? Because this was a right triangle. Please don't use it on any other triangle. I want to say this. Please don't, like on the test, on the exam, there will not be right triangles. Like, unless you have to classify it. But I don't think I've ever seen you having to use Pythagorean theorem. So if you do use it, you must have a 90 there, or else use sine law, right? You could have used sine law here. Sine of 90 over 3.9, sine of E over that, and then figure out the angles that way, okay? All right, skip a few pages. I'm going to ask you to go to page 20. That bridge. There was something like this on an old exam. Okay, if you're talking right now, it'll be regarding this. So what is it asking? How long is the bridge based on the information that you've got here? Okay. You may have to use sine law, cosine law. You can use anything you have to in order to figure out how long the bridge is. So we want to know from here all the way to the other end, how long is this bridge? Okay. So you have some measurements here, and you've got measurements there, right? So you do know things there. So give it a try. maybe I should say, do you see these markings? It's saying that this stretch from here to here is the same as that one, Okay. So if you could somehow figure out what this is, how many of those are there, right? So maybe you have to work with a right triangle, figure out the missing side, and then go with it. Thank you for patiently waiting. Some of you, this is the kind of stuff that you could expect. Like some of them are going to be pretty straightforward, and then every once in a while you're going to get one of those where you have to do a little bit more work to get there. Okay? I just don't want to see any blanks on the exam, guys. Give it an honest try. I'd rather you have it completely wrong, but tried, than to just be like blank, move on, right? Don't leave it blank, because then you have 0 chances. So what I would do in this case, because there's a 90 here, and I know that the 8 feet goes right there. By the way, 1 tick is feet, 2 ticks is inches, by the way. And so I don't know what this is, but I do know that this is 11.3 feet, right? So I can use Pythagorean theorem. This is one of the legs here. So leg is square root of 11.3 squared minus 8 squared. Make sure you do this first before you root. This would be 63.69, and then you get 7.9806 and something feet. And why am I not rounding yet? And some of you did round. I didn't make a big deal out of it today, but you're not done yet, because you got to go bridge, right? Bridge. Oh, sorry.
Wow.
Stop it. Out of context. I'm not posting this one. I bet you YouTube is going to just take it out anyways. That's your final answer. Sorry about that. I honestly was not thinking when I did that. It's one of those jokes that just happens, right? Anyways, I'm going to leave it there. If you wanted to calculate the interior angles, because I right now don't want to spend too much time on sine law, cosine law, that's why. So how about this? I will post the key to a bunch of pages. If you're willing to go back and kind of challenge yourselves, please do that, okay? Okay.